Hello, welcome. Let's try to solve another Leetcode problem 611, valid triangle number. So we are given an integer array nums, and we're going to return the number of triplets chosen from the arrays that can make triangles if we take them as the side lengths of a triangle. So let's just make a drawing. So this is going to be a triangle. So if we have the sides like A, B, C, so the triangle gonna meet the condition A plus B will be more than C. B plus C will be more than A. And A plus C will be more than B. So this is the condition of triangle. If it meets all the conditions, then it's gonna be a triangle. If it meets only one or two conditions, it may be not a triangle. So the condition is that if we meet all those three conditions, and then it's going to be a triangle. Let's just use the example. So A equal to 2, B equal to 3, C equal to 4. So 2 plus 3 more than 4, and 3 plus 4 more than 2, and 2 plus 4 more than 3. So this is the basic idea. But in this way, if we were to take all the triangle numbers, so it's going to be n cubic. Yeah, n to the power of 3, and n equals to 10 to the power of 3, n equal to 1000, so definitely it didn't work. So we needed to find a faster way to solve the problem. How can we make it faster? So currently we need to check all the conditions like A, B, C, A plus B, B plus C, and A plus C. So what if we just sort the array? For example, if we can sort A, B, C, so A, B, C, if we can sort it, it's going to be like 2, 3, 4. So those numbers inside the array going to be 2, 3, and 4. So we should know that for those three numbers, it's going to be A less than B and less than C. So in this situation, we just need to check two numbers. If A plus B more than C, if 2 plus 3 more than 4, and then it is a triangle, and we don't need to check other cases because it always meets the condition. So if A plus B, 2 plus 3 more than 4, A plus B more than C, so definitely B plus C more than A. So this is B, this is C, because C is bigger than A, so definitely B plus C more than A. And A plus C more than B, because C is more than and equal to B, so A plus C definitely more than B. So we just need to check one case, A plus B more than C. So after sorting, so A gonna be less than equal to B, B gonna be less than equal to C, and we just need to check one formula. But even checking one formula, the time complexity is gonna be the same in cubic. But how can we make it faster? So we can use a two-parter. So if we have many numbers like 4 numbers, maybe 2, 2, 3, 4. Yeah, how can we make it faster? So for example, if this 4 is the last number C, last side of our triangle, if this 4 is the side C, and then A and B must inside the subarray 2, 2, 3. Yeah, but how can we find A and B? And we can just define two powders. So this is the L index, and this is the R index. Yeah. So currently we just need to check if nums L plus nums R 2 plus 3 more than 4. So this means from 2, 3, 4 it must be a triangle. Yeah. If 2, 3, 4 is this 2, this 3, this 4 is a triangle, and then this 2, this 3, and this 4 must be a triangle. Because the array is sorted in increasing order, and this number must be more than and equal to this number 2. So here is a 2, maybe it is a 2.5, it doesn't matter. Yeah. So this number is going to be more than and equal to 2, so this number plus 3 definitely meets the condition. So in this way, we don't need to check all the possible cases like 2, 3, 4, like this 2, this 3, this 4, and this 2, this 3, and this 4. We can just check them together. We just need to use R minus L. It's going to be all the possible cases. So for example, if this way nums L plus nums R more than this number 4, So it means it is a triangle, but how many of them? It's going to be R minus L. This is a position R, this is a position L, so it's going to be equal to 2. So in this way, we find two triangles if we fixed these sides. This is going to be the longest sides of a triangle. It is a 2, 3, 4, and 2, 2. It is a 2, 3, 4, and this 2, this 3, this 4. Yeah. So after that, what are we going to do? We just need to shift the pointer R to the left. So this is going to be the R, and then nums L plus nums R, 2 plus 2 equal to 4. It is not a triangle. So in this way, what are we going to do? We just need to update the L pointer to the right, because maybe after shift the L pointer to the right, maybe we can find a bigger number. But currently in this case, we cannot find a bigger number because L equals to R. Yeah. But maybe there's a bigger number, more than 2. It is plus this number, more than 4. So we're going to continuously check like that by using two pointers. So this is the basic idea. So let me just prepare a better example. So maybe inside our array, we have something like 2, 3, 4, 5, 6. Yeah, this might be a better example. Why? Because if we fix this side, so first of all, the array is sorted in increase order. So in between, there are going to be some numbers maybe equal, it doesn't matter. So this is the L pointer, this is the R pointer. So nums L plus nums R going to be 7. 7 is more than 6, so this is a triangle. But how many of them? So we're going to use nums R minus L. So this is the index 3. This is the index 0. This is the index 2. So 2, 0, 1, 2, 3. Yeah, this is the index 3. So 3 minus 0, it means we find 3 triangles. It's going to be 2, 5, 6. 3, 5, 6, and 4, 5, 6. It's going to be 3 triangles. Definitely it meets the condition. But after that, what are we going to do? We're going to shift the R pointer to here. Yeah. So currently nums L, nums R, 2 plus 4 equals to 6. It is not a triangle, but what are we going to do? We might shift the left pointer. Maybe we can find a bigger number. So this is the nums L, this is the nums R, 3 plus 4 more than 6. It is a triangle. So how many of them? R minus L, it is 1. 3, 4, 6, it is 3, 4, 6, it is a triangle. So after that, what are we going to do? Since it is a triangle, so it means this is bigger. We might shift the R pointer to the left. So R pointer is going to be here. So currently L equals to R, so we're going to go out of the while loop because there are only two sides, 3 and 6. Definitely it is not a triangle. Yeah. Now we're going to use this kind of idea to solve the problem. So we're going to define an integer n. It's going to be nums length. And we can use arrays sort. We're going to sort the nums, and we can define a result. It's going to be 0. Now what are we going to do? We're going to define index I equal to 2, I less than n, and I plus plus. Yeah. Now since we are going to use the two pointers to solve the problem, we're going to define two variables, index L and R. So L going to starting from 0, and R going to starting from what is going to be R? Yeah, so L gonna be 0, and R gonna be I minus 1. Yeah, because currently nums I gonna be the longest size. This is gonna be the longest size, and the two pointers are gonna find how many of them. Yeah. So while L less than R is nums L plus nums R more than nums I. So this means we've already found a triangle, but how many of them? We're going to use the result plus R minus L and R minus minus. So else we're going to use L plus plus. Yeah. So in this way we find how many of them, and we just need to return the final result. Now let me just run it to check if it works. So here I forgot about the semicolon. Now let me just run it. As you can see, it works. Now let me just submit it. Yeah, as you can see, it works and it's passed for all testing cases, and it's pretty fast because the time complexity is O(n) squared. So from here, this is the sorting. After sorting, the time complexity is n log n time. And here we have a for loop. Here we have a while loop by using two pointers. Yeah. So this is O(n), the for loop is O(n), so the time complexity gonna be O(n) squared, as n is just 1000, so it's not a big number. That is why it works. I think that's all about it. Thanks for watching. See you next time.